Imagine holding a flashlight in your hand. You click it on, and a beam shoots across the room. Simple, right? Now, what if I told you that the light coming from that flashlight isn't just illuminating matter? It is matter in its purest, most fundamental form? What if every atom in your body, every cell, every thought you've ever had started as light? Not metaphorically, literally. Here's the thing that's going to shake everything you think, Physicists have discovered that matter and light aren't different things. They're the same thing in different states. It's like ice and steam, completely different properties, but both are water. Except in this case, we're talking about the fabric of reality itself. In 1905, Albert Einstein published a little equation that you've probably seen on t-shirts, E=mc. But here's what they don't tell you in school. This equation doesn't just mean energy and mass are related. It means they're interchangeable. It means that the light streaming from the sun, the radio waves passing through your body right now, the photons hitting your retina, all of it can become matter. And all matter can become light. But it gets stranger. In 2014, physicists at Imperial College London figured out how to turn light directly into matter using a process they called the Bredt-Wheeler process. They showed mathematically that if you smash two photons together with enough energy, you get an electron and a positron actual particles with mass appearing out of pure light. Matter from nothing but electromagnetic radiation? Now here's where your brain should start tingling. If light can become matter, and matter can become light, which one came first? When the universe exploded into existence 13.8 billion years ago in the Big Bang, what was there first, light or matter? The answer is going to rewrite everything you think you understand about existence itself. Before we dive into this reality-shattering journey, do me a favor, hit that like button right now, subscribe to this channel, and drop a comment telling me where in the world you're watching from and what time it is for you right now. I want to know how many different countries are about to have their minds blown simultaneously. Are you in Tokyo at midnight? London in the afternoon? Los Angeles just waking up? Let me know, because what you're about to learn connects all of us in ways you can't even imagine yet. Let's start with something you can see right now. Look at your hand. Go ahead, actually look at it. That hand is made of atoms, roughly 7 octillion of them. Each atom has a nucleus surrounded by electrons. Solid, physical, real. Now here's the first crack in reality. Those atoms are 99.9999999% empty space. If you removed all the empty space from all the humans on Earth, we'd fit into a sugar cube. So what's filling that space? What's holding your hand together? The answer is forces, electromagnetic forces, specifically. And how are forces transmitted in quantum physics? Through particles called photons. Yes, light particles. Your hand is literally held together by the same stuff that comes out of a light bulb. But let's go deeper. What are electrons made of? We used to think they were the smallest things, indivisible. Then we discovered quarks. Protons and neutrons are made of quarks. But electrons? Electrons are what physicists call fundamental particles. They can't be broken down further. And here's the wild part. Electrons aren't really particles at all. They're excitations in quantum fields. Think of it like ripples in a pond. The water is the field, and the ripples are the particles. Now, photons, light particles, they're also excitations in a quantum field, the electromagnetic field. So matter particles and light particles are both just different types of waves in different fields. They're made of the same fundamental stuff, quantum field oscillations. Richard Feynman, one of the greatest physicists of the 20th century, won the Nobel Prize in 1965 for his work on quantum electrodynamics, the theory of how light and matter interact. His calculations showed that electrons are constantly emitting and reabsorbing photons, even when they're just sitting there. Your body right now is generating a cloud of virtual photons around every electron in every atom. You are, quite literally, glowing with invisible light at the quantum level. Think of it like this. Imagine a dance floor with dancers representing matter particles and the music representing light. The dancers move to the music, but the music is also created by the dancers' movements. They're not separate, they're part of the same system, feeding off each other. You can't have one without the other. Here's where it gets personal. Every single electron in your brain, firing signals that create your thoughts, is doing this quantum dance with light. Your consciousness, the thing reading these words right now, emerges from a pattern of matter that's inseparable from light. You're not just made of stardust. You're made of starlight, but we're just getting started. That's the warm-up. Now we're going to travel back to the beginning of time itself, to the moment when the universe was nothing but light, and watch how everything you see around you crystallized out of that primordial glow. Close your eyes for a second and imagine absolute nothingness. Not dark space with stars, actual nothing. No space, no time, no matter, no light, nothing. Now imagine that nothing suddenly exploding into everything in a trillionth of a trillionth of a trillionth of a second. That's the Big Bang. But here's what they don't tell you in the documentaries. For the first 380,000 years after the Big Bang, there was no matter as we know it. There was only light. Let me paint you a picture of the infant universe. In the first few moments after the Big Bang, the temperature was 10 trillion degrees Celsius. That's 1,000,000 times hotter than the core of the sun. At these temperatures, matter couldn't exist. Why? Because to make an atom, you need electrons to orbit a nucleus. But electrons are held in orbit by electromagnetic force. Essentially, they're trapped by photons. When temperatures are too high, photons have so much energy that they knock electrons away the instant they try to settle down. It's like trying to build a house in a hurricane. So for nearly 400,000 years, the universe was just a hot, dense soup of free electrons, protons, neutrons, and an overwhelming sea of high-energy photons light. This period is called the photon epoch. The universe was so filled with light that if you were there, you couldn't see anything. The photons were constantly scattering off the free electrons, like trying to see through fog, so thick you could cut it with a knife. Then something magical happened. Around 380,000 years after the Big Bang, the universe cooled to about 3,000 degrees Celsius, still hot enough to melt any metal, but cool enough for electrons and nuclei to finally bind together and form the first atoms. This moment is called recombination, and it's one of the most important events in cosmic history. When electrons settled into atoms, the photons stopped scattering. For the first time, light could travel freely through space. The universe became transparent, and that ancient light is still traveling through space today. We call it the cosmic microwave background radiation, and it's the oldest light in the universe. In 1964, two physicists named Arno Penzias and Robert Wilson accidentally discovered this ancient light using a radio antenna, and they won the Nobel Prize for it in 1978. They thought they had bird droppings interfering with their equipment, but what they'd actually found was the afterglow of creation itself. Here's the mind-blowing part. You can see this ancient light on your TV. If you tune an old analog TV to a channel with no station, about 1% of that static is photons left over from the Big Bang. You're literally watching the birth of the universe on your television screen. But let's rewind even further. What happened in those first few microseconds after the Big Bang? This is where it gets truly strange. In the first microsecond, the universe was so hot that even protons and neutrons couldn't exist. There were only quarks and gluons, the fundamental building blocks of matter, swimming in a sea of photons. Matter and light were in perfect equilibrium, constantly transforming into each other. Quarks would collide and annihilate into pure energy photons. Photons would collide and create quark-anti-quark pairs. It was a cosmic dance of creation and destruction, happening trillions upon trillions of times per second. The universe was a boiling cauldron where the line between matter and light didn't just blur, it didn't exist at all. And here's the question that should be haunting you right now. If matter and light were constantly converting into each other, why did any matter survive at all? Why didn't everything just annihilate into pure light? Why is there something rather than nothing? The answer involves one of the deepest mysteries in physics: matter-antimatter asymmetry. For every billion antimatter particles created, there were 1,000,000,001 matter particles. When the universe cooled enough for the annihilation to stop, that tiny excess, 1 part in a billion, was all that remained. That minuscule imbalance is the reason you exist. You are made from the 1 billionth that survived. Think about that for a moment. Your entire body, every atom in it, exists because of a tiny statistical fluctuation in the first second of the universe. You're not just rare. You're impossibly, cosmically, miraculously rare. But here's what's really going to cook your noodle. Where did that asymmetry come from? Why were there more matter particles than antimatter particles? We don't know. It's one of the biggest unsolved problems in physics. Some physicists think it has to do with a difference in how matter and antimatter behave at the quantum level, something called CP violation. Others think there might be entirely new physics we haven't discovered yet. What we do know is this: in the beginning, there was light. Then, through processes we're still trying to understand, some of that light crystallized into matter. The universe transitioned from a state of pure energy to a state where energy could take solid form. Light became matter, and that matter eventually became you. Now, here's where we're going next, and I promise you're not ready for this. We're going to look at how physicists in modern laboratories are recreating that moment. They're turning light back into matter right now, in experiments happening as you watch this. And what they're discovering is challenging everything we thought we knew about the boundary between energy and substance. Picture the most powerful microscope you can imagine. Now multiply that power by 1,000,000,000,000. You're still not close to what scientists at places like CERN, the European Organization for Nuclear Research, are working with. They have machines called particle colliders that accelerate particles to 99.9999991%, the speed of light, then smash them together to see what comes out. In 2012, physicists at CERN discovered the Higgs boson particle that explains why other particles have mass. Peter Higgs predicted this particle in 1964, and it took nearly 50 years and a 17-mile underground ring to find it. But here's what's fascinating for our story. The Higgs boson decays in a tiny fraction of a second into photons light. Mass literally transforms back into light right before the scientists' sensors. But that's old news now. What's happening in labs today is even stranger. Remember I mentioned the Breit-Wheeler process earlier? In 1934, 2 physicists named Gregory Breit and John Wheeler predicted that if you collided 2 photons with enough energy, you could create matter, specifically an electron and a positron. But they thought it would be impossible to actually do this in a lab. The energies required were too high, and you can't just make photons collide easily because they pass right through each other. Fast forward to 2014. Physicist Oliver Pike and his team at Imperial College London figured out a way to do it. Their experiment involves firing electrons at a piece of gold. When the electrons smash into the gold nuclei, they emit high-energy photons gamma rays. These gamma rays then pass through a tiny gold container called a hohlraum. Inside the hohlraum, there's another intense beam of light from one of the world's most powerful lasers. The gamma rays collide with the laser photons, and boom matter appears. Electrons and positrons, conjured from light. Think of it like this. Imagine you have 2 ripples on a pond moving toward each other. When they meet, instead of just passing through, they somehow create a solid pebble that drops into the water. That's essentially what's happening here, except the pond is the quantum field. The ripples are photons, and the pebble is matter. The experiment hasn't been fully completed yet as of early 2025, but the theoretical framework is solid, and physicists are confident it will work. When it does, It will be the first time in human history that we've created matter directly from light in a controlled laboratory setting. We'll have literally bottled a piece of the Big Bang. But here's what should really blow your mind. This process is happening naturally all the time in space. In the intense magnetic fields around neutron stars and black holes, photons are constantly being converted into matter and back again. In gamma-ray bursts, the most powerful explosions in the universe, after the Big Bang light is so energetic that it spontaneously creates matter. In 2018, astronomers using the Very Gamma-Ray Space Telescope observed a gamma-ray burst that was producing matter at an incredible rate. The light from this explosion was creating thousands of electrons and positrons per second. They were watching light turn into matter in real time, across billions of light years of space. Now let me connect this to something you experience every day: light pressure. Yes, light has pressure. It can push things. When photons hit a surface, they transfer momentum. It's tiny. A flashlight produces about the same pressure as a grain of sand, but it's real. This is how solar sails work in space exploration. Spacecraft can literally surf on light. But if light can push things, doesn't that mean light has properties we associate with matter? Momentum is something we think particles have, not waves, yet light has it. This duality, light, acting like both a wave and a particle, is one of the central mysteries of quantum mechanics. In 1924, a French physicist named Louis de Broglie had a wild idea. If light can act like particles, can matter act like waves? Turns out, yes. Electrons, protons, even entire atoms exhibit wave-like behavior. We can create interference patterns with them, just like we do with light. Matter has wavelength and frequency. Matter is waves, just like light. So we have light behaving like matter, and matter behaving like light. The boundary between them isn't just blurry, it's fundamentally arbitrary. It depends on how you measure them, how you interact with them. The universe doesn't distinguish between matter and light the way our brains do. They're just different manifestations of quantum fields. Here's an experiment you can think about: the double-slit experiment. You shoot particles, let's say electrons, through two narrow slits. On the other side, you have a detector screen. If electrons were just particles, you'd expect two bands on the screen corresponding to the two slits. But that's not what happens. You get an interference pattern, multiple bands, just like when you send light waves through two slits. The electrons are acting like waves, interfering with themselves. But here's the kicker. If you put a detector at the slits to see which slit each electron goes through, the interference pattern disappears. The electrons start acting like particles again. It's as if the universe knows when you're watching and changes its behavior accordingly. This is called the observer effect, and it's been confirmed in thousands of experiments. Matter doesn't have definite properties until you measure them. Now, apply this to our question. What if light is the first form of matter? If matter and light are fundamentally the same thing, just measured differently, then asking which came first is like asking whether the chicken or the egg came first. They're both manifestations of something deeper: quantum fields. The universe didn't start with light that became matter. It started with quantum fields that could manifest as either light or matter depending on conditions. But hold on, because we're about to go even deeper. What if those quantum fields themselves aren't the deepest level? What if there's something even more fundamental than quantum fields? This is where modern theoretical physics gets truly mind-bending, and it's going to change how you think about reality itself. Let me ask you something. What is energy? No, really. You use the word all the time. I don't have enough energy today. Renewable energy. Energy drinks? But what is it? Here's the unsettling truth. Physicists don't really know. We can measure energy, calculate it, convert it from one form to another. We have equations for it. But what energy actually is at the most fundamental level? That's still a mystery. What we do know is that energy is the capacity to do work, to cause change. And here's the critical insight. Energy is never created or destroyed. It only changes form. This is the first law of thermodynamics, and it's one of the most tested and confirmed laws in all of science. So when light becomes matter, energy isn't being created. It's changing form. E equals mc tells us exactly how much energy is stored in a given amount of mass. Take your mass in kilograms, multiply it by the speed of light squared, about 90 quadrillion, and that's how much energy is locked inside your body. For a 70-kilogram person, that's roughly 6.3 xyp joules, enough energy to power the entire United States for about 20 years. You are, quite literally, made of frozen light, solidified energy. Your atoms are just energy locked into a stable pattern by the forces of nature. But let's push this even further. In 1915, Albert Einstein published his general theory of relativity. This theory showed that gravity isn't a force in the traditional sense. It's a curvature of spacetime caused by mass and energy. Heavy objects bend space around them like a bowling ball on a trampoline, and other objects roll toward that curve. But here's the thing. If mass is just concentrated energy, and energy curves spacetime, then light, which carries energy, should also curve spacetime. And it does. In 1919, during a solar eclipse, the British astronomer Arthur Eddington measured the positions of stars near the sun and found that their light was bent by the sun's gravity, exactly as Einstein predicted. This was the experiment that made Einstein world famous. Light has no mass, but it has energy, and energy gravitates. Light can't escape from black holes because the spacetime curvature is so extreme that there are no paths leading outward. Even light, traveling at the fastest speed possible, can't climb out of that pit. Now connect this back to our story. In the early universe, there was so much energy concentrated in such a small space that spacetime itself was violently curved. The universe wasn't just full of light. The light itself was bending reality. The fabric of space and time was being warped by pure energy. And here's where it gets truly wild. Some physicists think spacetime itself might emerge from quantum entanglement, the spooky connection between particles that Einstein famously hated. Mark van Ramsdonk at the University of British Columbia has shown mathematically that in certain models, if you remove quantum entanglement between regions, spacetime itself tears apart. Space might not be fundamental. It might emerge from quantum connections between particles. Think about what that means. Space and time might be products of quantum information. And if matter and light are both excitations in quantum fields, and those fields exist in spacetime, but spacetime emerges from quantum entanglement, then we're looking at reality as a kind of hologram, a projection of quantum information into the three-dimensional space we perceive. This idea is called the holographic principle, and it was developed by Gerard 't Hooft and Leonard Susskind in the 1990s. Basic idea is that all the information contained in a volume of space can be encoded on the boundary of that space, like a hologram on a two-dimensional surface that contains a three-dimensional image. If this is true, and many physicists think it is, then asking whether light or matter came first is missing the point. They're both projections of something more fundamental, quantum information. The universe is, at its deepest level, made of information. Matter and light are just different ways that information manifests in spacetime. Let me give you an analogy. Think of a video game. On the screen, you see characters, environments, objects. They seem solid and real within the game world. But zoom out, and they're all just data ones and zeros being processed by the computer and projected onto a screen. The characters aren't fundamentally different from the light effects in the game. They're both made of the same underlying data. That might be what our universe is like. Particles, light, space, time, all of it might be emergent properties of quantum information being processed by ... something. We don't know what. The universe itself? Some deeper substrate we haven't discovered yet? This is where physics meets philosophy, and where we have to confront the possibility that our most fundamental intuitions about reality might be wrong. We think matter is solid, real, tangible. We think light is insubstantial, just waves passing through space. But at the quantum level, those distinctions evaporate. Everything is patterns, information, process. Now, before your brain completely melts, let me ground this in something practical. The principles we're talking about, quantum mechanics, relativity, field theory, they're not just abstract ideas. They're the foundation of technology you use every day. Your smartphone relies on quantum mechanics. The transistors in the processor exploit quantum tunneling electrons, passing through barriers they shouldn't be able to pass through classically. GPS satellites use corrections from general relativity to stay accurate. MRI machines use quantum spin states to image your body. LED lights work because of quantum energy levels in semiconductors. The fact that light can become matter and matter can become light isn't science fiction. It's the reason nuclear power plants work, why the sun shines, why PET scanners in hospitals can detect cancer. When you have a PET scan, you're injected with radioactive material that emits positrons. Those positrons collide with electrons in your body and annihilate into photons light. The machine detects those photons to create an image of your organs. You're being imaged by the light created from matter annihilation. So when I say light is the first form of matter, I'm not speaking metaphorically or mystically. I'm describing the actual physics of how the universe works. And here's what's coming next. We're going to explore how this understanding is changing our view of what's possible. If we can convert light to matter and matter to light, what does that mean for the future? Could we 3D print objects out of light? Could we transmit matter through space as information? The answers are going to sound like science fiction, but they're based on real physics being explored right now. Let's talk about replicators from Star Trek. You know, the device where Captain Picard says, "Tea, Earl Grey, hot," and a cup of tea materializes out of thin air? Sounds like fantasy, right? But based on what we've learned so far, is it really impossible? Think about what a replicator would need to do. Convert energy into matter in a specific arrangement. We already know energy and matter are interchangeable E equals mc. We already know that light can be converted into particles. The question isn't whether it's possible in principle. The question is whether it's practical. Here's the problem. Creating matter from energy is spectacularly inefficient at the scales we're talking about. Remember that equation? The speed of light squared is a huge number. To create 1 kilogram of matter, you need 9 times 10 to the 16th joules of energy. That's about 21 megatons of TNT, equivalent to the largest nuclear bomb ever tested. So while we can create electrons and positrons from light in a lab, creating a cup of tea with its trillions upon trillions of atoms arranged in complex molecular structures would require more energy than currently available to human civilization. It's theoretically possible, but practically absurd with our current technology. But let's imagine for a moment we solved the energy problem. Let's say we had fusion reactors, or antimatter drives, or some other technology that could generate enormous amounts of energy cheaply. Could we then build a replicator? The second challenge is information. To create a cup of tea, you don't just need the atoms, you need them arranged correctly. The molecules of water, the polyphenols and caffeine in the tea, the ceramic structure of the cup. That's an insane amount of information. Every atom's position and velocity would need to be specified. But guess what? We're getting better at this. In 2013, researchers at the University of New South Wales in Australia demonstrated that they could place individual phosphorus atoms in silicon with atomic precision, creating the thinnest transistors ever made. They're literally building structures atom by atom. In 2018, IBM researchers spelled out the words, "A boy and his atom," by positioning individual atoms and filming them with a scanning, tunneling microscope. They created the world's smallest movie by arranging 65 atoms frame by frame. We're not talking about converting light to matter at this scale. We're assembling existing atoms, but it shows that manipulating matter at the atomic level is becoming possible. Combine that capability with the ability to create matter from energy, and suddenly, our replicator doesn't seem quite so fictional anymore. But here's where it gets really interesting. What if we went the other direction? What if, instead of materializing objects from energy, we converted objects into energy into light, transmitted that energy as information, and then reconverted it at the destination? This is essentially what happens in particle accelerators all the time, just not with complex objects. We accelerate particles to high speeds, smash them together, convert them to energy, and then watch as that energy creates new particles. We're transforming matter through an energy state. Could we do this with a person? Could we scan someone, convert their atoms to energy, transmit that energy, and reconstruct them elsewhere? This is the transporter from Star Trek, and it raises profound questions about identity and consciousness. But let's set aside the philosophical questions for a moment and focus on the physics. The amount of energy stored in a human body is staggering, remember. About 6.3 XYP joules for a 70-kilogram person. If you converted a person to energy and something went wrong during transmission, you'd have an explosion that would dwarf the largest nuclear weapons. And that's not even the hardest part. The hardest part is the information. A human body contains approximately 7 by YY atoms. Each atom's position, momentum, and quantum state would need to be measured and recorded. But the Heisenberg uncertainty principle says you can't measure both position and momentum precisely at the same time. The act of measuring one affects the other. Some physicists think this makes beaming impossible in principle. Others think we could get around it using quantum teleportation, a process where the quantum state of a particle is transferred to another particle without the original particle physically traveling. This has been demonstrated with photons over distances of hundreds of kilometers. In 2017, Chinese scientists used the Mishi satellite to quantum teleport photons from Tibet to orbiting satellites and back down to China, over 1,200 kilometers away. They transferred the quantum state of light particles across space without the particles themselves making the journey. Could this be scaled up to complex matter? To a human being? Most physicists are deeply skeptical. The quantum state of every particle in your body would need to be entangled with particles at the destination, then measured and transferred, all without errors. Given that quantum states are incredibly fragile and easily disrupted, this seems impossibly difficult. But here's the thing. We've been wrong about impossible before. Heavier than air flight was impossible until it wasn't. Breaking the sound barrier was impossible until it wasn't. Landing on the moon was science fiction until it wasn't. And we're learning more about the relationship between matter, energy, and information every day. In 2019, physicists proposed using the Breet-Wheeler process, turning light into matter, to create antimatter drives for spacecraft. If we could generate antimatter from light, store it, and then annihilate it with matter for propulsion, we could theoretically reach a significant fraction of the speed of light. The key insight is this. Once you understand that matter is just crystallized energy, and light is energy in motion, you start to see possibilities that seem like magic, but are actually just advanced applications of fundamental physics. Now, let me ask you something personal. How does it feel knowing that you're not as solid as you think? That your body is mostly empty space held together by forces transmitted by light particles? That every atom in your body was once pure light in the first moments after the Big Bang? Does it make you feel less real? Or does it make you feel connected to something vast and cosmic? Because here's where we're heading next. The implications of all this for who you are and what it means to be human. If you're made of light, if your atoms are constantly exchanging photons with the rest of the universe, then where do you end and the universe begin? That boundary is a lot blurrier than you think. Right now, as you're processing these words, Your body is engaged in a constant dialogue with the universe. You're not a closed system. You're an open, dynamic process, constantly exchanging energy and matter with your environment. Every breath you take, you're inhaling atoms that were once part of other organisms, other people. There's a famous calculation that shows that with every breath, you're inhaling atoms that were once breathed by Julius Caesar, by Cleopatra, by Jesus, by Buddha. The atmosphere has been mixing for thousands of years, and atoms don't stay put. But it goes deeper than that. You're also constantly absorbing and emitting light. Your body temperature is about 37 degrees Celsius, which means you're glowing in the infrared spectrum. You're literally emitting light right now, about 100 watts of thermal radiation. If you had infrared vision, you could see people glowing in the dark, and you're absorbing light too. Sunlight hitting your skin triggers chemical reactions that produce vitamin D. Your retinas convert photons into electrical signals in your brain. Light is constantly interacting with your body, changing it, informing it. At the quantum level, it's even more intimate. Remember those virtual photons surrounding every electron? The electromagnetic force holding your atoms together is mediated by photon exchange. Your body is permeated by a field of light at the quantum level. Now think about this. If your atoms are constantly exchanging photons, constantly radiating energy, constantly being replaced by new atoms from food and water and air, then what part of you is permanent? What part of you is the essential you? The atoms in your body are replaced on a regular cycle. Every 7 to 10 years, almost every atom in your body has been swapped out for a different atom. The carbon atoms that make up your DNA right now weren't there a decade ago. You're like a wave in the ocean. The form persists, but the water is constantly changing. So who are you? You're not your atoms. Those come and go. You're not even your specific matter. That's temporary. You're a pattern, a process, an organization of energy and information that maintains itself over time despite constant flux. You're a standing wave in the quantum field, a temporary crystallization of light into a form that can experience itself. This isn't mysticism, this is physics. The great physicist Erwin Schrödinger, who developed the fundamental equation of quantum mechanics, wrote a book called What is Life?, where he explored these ideas. He concluded that living organisms are systems that maintain order by increasing entropy in their environment. We're islands of complexity in the universe, trending toward disorder. And we maintain that complexity by constantly consuming energy and radiating waste heat. We're dissipative structures patterns that persist far from equilibrium by channeling energy through ourselves. Like a whirlpool in a river. The whirlpool isn't the water is constantly flowing through. The whirlpool is the pattern, the organization, the form that persists. And if you zoom out far enough, stars are the same thing. Stars are stable patterns of matter held together by gravity, converting mass into light through fusion. They're dissipative structures on a cosmic scale, maintaining their form by radiating energy. You and the sun are fundamentally similar processes. You're both temporary concentrations of order, both radiating light, both destined to eventually dissipate. The difference is just scale and complexity. Now here's where this gets profound. If consciousness is a property of complex organized systems processing information, and if your body is a temporary pattern rather than a permanent object, then consciousness itself is a process, not a thing. It's not located in your atoms. It's not a substance. It's an activity, the activity of information processing in a complex system. And if consciousness is information processing, and information is fundamental to physics, then consciousness might not be as special or separate from the physical universe as we think. It might be what information processing feels like from the inside. The physicist John Wheeler, who coined the term black hole and worked with Einstein, proposed what he called the participatory universe. His idea was that observers conscious entities play a role in bringing the universe into existence by collapsing quantum wave functions through observation. The universe isn't just something we observe. It's something we participate in creating moment by moment. This might sound crazy, but remember the double-slit experiment. Particles don't have definite positions until measured. They exist in superposition multiple states at once until observation forces them to choose a state. Consciousness, or at least measurement, seems to play a role in determining reality. Now, most physicists don't think consciousness is special in this regard. They think any interaction that constitutes a measurement, even one involving a non-conscious measuring device, causes wave function collapse. But the fact remains, observation changes reality at the quantum level. You are not separate from the universe. You're part of it, actively participating in its evolution. Every observation you make, every decision, every thought, is part of the universe becoming aware of itself. Carl Sagan famously said, "We are a way for the cosmos to know itself." He meant that literally. You're made of atoms forged in stars, organized into patterns complex enough to wonder about your own origins. The universe has spent 13.8 billion years creating the conditions for you to exist and ask these questions. And if light is the first form of matter, then you're not just made of stardust. You're made of the light from the Big Bang, evolved and organized into a form capable of understanding where you came from. Let that sink in for a moment. The light from the beginning of time is reading these words right now through your eyes. The same light that filled the infant universe has been transformed over billions of years into you. Does that change how you feel about yourself? Does it change how you feel about other people, knowing they're made of the same ancient light? Does it change how you feel about the universe, knowing that it's not just your home, but your very substance? I want you to take a moment seriously. Pause and think about the most beautiful thing you've ever seen. Maybe it's a sunset, or a person you love, or a work of art, or a child's face. Now realize, what you're looking at is light that's been transformed into matter, organized into patterns of stunning complexity, reflecting light back to your eyes, where it's converted into electrical signals in your brain. Your light, looking at light, transformed by light. It's all light, all the way down, in different configurations and forms. And here's what we're going to explore next. If we're all made of light, if consciousness is information processing, and if information is fundamental to reality, then what happens when we die? Where does the pattern go? Where does the light go? The answer involves some of the strangest and most beautiful ideas in physics. And I promise you're not ready for where this is heading. Let's confront the thing everyone thinks about, but rarely discusses openly. Death, the end of your pattern. The dissipation of the organization that is you. What happens to the light? First, the obvious physics. When you die, the chemical processes that maintain your body's organization stop. Without the constant input of energy from food, without the oxygen from breathing, the complex structures start to break down. Entropy wins. Your body returns to simpler forms. The atoms that made up your body don't disappear atoms, don't do that. They get recycled. Some become food for bacteria and fungi. Some disperse into the soil and get taken up by plants. Some evaporate into the atmosphere. Given enough time, the specific atoms that were once you will be scattered across the earth, becoming parts of thousands of other organisms. But what about the pattern? What about the information that was your specific organization, your memories, your personality, your consciousness? From a purely physical standpoint, that information is lost. It degrades with the breakdown of your brain structure. The neural connections that encoded your memories dissolve. The patterns of electrical activity that generated your thoughts cease. This is the materialist view, and it's consistent with everything we know about physics. When the physical substrate disappears, the pattern it supported disappears with it. No physical body, no consciousness. But let's consider something strange. The laws of physics are reversible at the fundamental level. If you filmed subatomic particles interacting and played the film backward, it would look just as valid forward. Time reversal symmetry is a fundamental feature of quantum mechanics and classical mechanics. Yet we see irreversibility everywhere in the macroscopic world. Eggs break, but don't unbreak. Coffee cools, but doesn't spontaneously heat up. People age and die, but don't reverse age back to infancy. This is the second law of thermodynamics. Entropy increases over time in closed systems. But here's the thing. The second law is statistical, not absolute. It says entropy tends to increase, not that it must increase in every case. In principle, all the broken pieces of an egg could spontaneously reassemble. It's just so spectacularly unlikely that it effectively never happens. Now here's where it gets weird. In a quantum universe with infinite time, every possible configuration will eventually occur. This is called the Poincare recurrence theorem. If you wait long enough, an incomprehensibly long time, much longer than the current age of the universe, the specific pattern of atoms that was, you could spontaneously reassemble. The physicist Ludwig Boltzmann suggested that our entire universe might be a random fluctuation in a vast equilibrium. A Boltzmann brain momentarily emerging from chaos. If true, then your specific pattern could emerge again, purely by chance, in the far future. This is cold comfort, of course. You wouldn't be you in any continuous sense. You'd be a new pattern that happened to be identical. There'd be no connection, no continuity of consciousness. Unless ... And here's where physics meets speculation. Unless information is somehow conserved in ways we don't understand. There's a principle in physics called unitarity, which says that information is never truly destroyed. When you throw a book into a black hole, the information in that book doesn't vanish. It's encoded in the black hole's event horizon. Stephen Hawking spent years working on this problem, initially thinking information could be destroyed, but eventually accepting that it must be preserved somehow. If information can't be destroyed, where does the information that is you go when you die? We don't know. Maybe it's encoded in the quantum state of every atom that was once part of you, now scattered across the earth and beyond. Maybe consciousness leaves some kind of imprint on the quantum fields. This sounds mystical, but it's actually a serious question in physics. Max Tegmark at MIT has proposed that consciousness is a particular state of matter, what he calls perceptronium, a state where matter processes information in specific ways. If consciousness is a physical state, then maybe it leaves physical traces we don't yet know how to detect. But let's be honest, this is highly speculative. The evidence we have points to consciousness being dependent on functioning brains, and when brains stop, consciousness stops. Everything else is hope, a wishful thinking dressed up in physics language. Yet there's something profound even in the materialist view. The atoms that make up your body, the light that illuminates your experience, the energy that powers your thoughts, none of it is destroyed when you die. It's transformed, redistributed, recycled into new forms. You're part of an endless cycle of transformation. The calcium in your bones will become part of the Earth's crust, then maybe dissolve in the ocean, then get incorporated into coral reefs or the shells of sea creatures. The carbon in your DNA will become part of trees, which will photosynthesize sunlight and grow, which might be eaten by animals, which will live and die and complete their own cycles. The energy that animated you will dissipate as heat into the environment, contributing its tiny fraction to the thermal energy of the planet, which radiates out into space as infrared light. You will, quite literally, become light again. Just as you started as light 13.8 billion years ago in the Big Bang, you'll return to light, scattered across the cosmos. There's a kind of immortality in that. Not the personal immortality of preserved consciousness, but the immortality of substance. You're not separate from the universe. You've never been separate. You're a temporary organization of universe stuff, experiencing itself, and when that organization dissolves, this stuff remains, ready to be organized into new patterns. Every atom in your body has been part of countless other organisms before you. You're wearing the recycled substance of dinosaurs, of ancient ferns, of the first bacteria, of the primordial gas clouds that collapsed to form our solar system. And after you, those atoms will go on to be part of countless other things. You're not a noun, a fixed thing. You're a verb, an ongoing process of the universe, organizing itself into patterns that can experience and understand. And here's the thing. While you exist in this pattern, while the organization holds, you have something miraculous. You have consciousness. You have the ability to appreciate the beauty of light, to understand the physics of matter and energy, to contemplate your own existence. The fact that it's temporary doesn't make it less valuable. It makes it more precious. You're a brief candle, yes, but you burn bright. You're a momentary fluctuation in entropy, but you generate meaning, beauty, love, understanding. And if light is the first form of matter, then you are light experiencing itself in one of its infinite temporary forms. The same light that filled the universe 13.8 billion years ago has become complex enough to wonder about its own nature. That's not diminishment. That's glory. Now, I know this section might feel heavy. We've gone from abstract physics to very personal territory. But this is important. Understanding what we're made of, understanding our place in the universe, changes how we live. It changes what we value, how we treat others, what we think matters. And we're not done yet, because there's one more aspect of this light-matter relationship that's going to tie everything together and possibly change how you see your purpose in life. Stay with me, because this final section is where everything we've learned becomes not just intellectually interesting, but personally transformative. Let me tell you about a photon that began its journey 13.8 billion years ago, in the first moments after the Big Bang. This photon was part of the primordial light that filled the infant universe, the light we now call the cosmic microwave background. For 380,000 years, this photon bounced around in the dense soup of matter and radiation, scattering off electrons billions of times. Then came recombination, the moment when electrons and nuclei bound together to form atoms. Suddenly, our photon was free. It could travel unimpeded through space. And travel it did. For 13.8 billion years, this photon moved through the expanding universe, its wavelength stretching as space itself expanded, cooling from the visible spectrum down to microwaves. Then, on a particular day in the early 21st century, this photon, having traveled across the entire observable universe, struck a radio telescope on Earth. It was detected, measured, and contributed its tiny bit of information to our map of the cosmic microwave background. That photon's journey, which began at the birth of time, ended by increasing human knowledge about the universe's origins. Now, here's the thing. You can tell a similar story about every photon, every particle, every bit of matter and energy in the universe. Everything is on a journey. Everything has a history, and all of it is connected. The carbon atoms in your body were forged inside stars that lived and died before our sun was born. Those stars collected hydrogen and helium from the Big Bang, compressed it under immense gravity and temperature, fused it into heavier elements through nucleosynthesis, and then exploded as supernova, scattering those elements into space. The oxygen you're breathing right now was made inside a massive star, at least 5 times more massive than the sun, in a region where temperatures reached billions of degrees. That star died in a catastrophic explosion, and the oxygen was blown out into interstellar space, where it eventually became part of the gas cloud that collapsed to form our solar system. The iron in your blood, which carries oxygen to your cells, keeping you alive, was created in the core collapse supernova of a star, at least 8 times the mass of the sun. Iron is the end of the line for fusion. Making iron consumes energy rather than producing it. When a star's core turns to iron, it can no longer support itself against gravity. The core collapses in less than a second, and the rebound generates a shockwave that destroys the star. You carry the death throes of ancient stars in your very blood. Now think about this. Those stars, those supernova explosions, the formation of planets, the origin of life, the evolution of complex organisms, the development of brains capable of consciousness. All of this is the universe organizing itself into increasingly complex patterns. And the thing driving this organization is light. Energy from the sun powers photosynthesis, which creates the chemical energy that powers the biosphere. Nearly all life on Earth is ultimately solar-powered. We're chemical batteries storing sunlight in molecular bonds, and we run on that stored light. But it's not just about energy, it's about information. Life is fundamentally about preserving and transmitting information encoded in DNA. Evolution is an evolution, information processing algorithm that explores possibility space, finding patterns that work, that survive, that reproduce. And consciousness? Consciousness is the universe processing information about itself. When you learn something about how the world works, when you understand a scientific principle or appreciate a mathematical proof, that's the universe knowing itself through you. You're not just a random collection of atoms. You're part of an enormous, cosmic-scale process of increasing complexity and awareness. From the undifferentiated light of the Big Bang to the structured matter of atoms, from simple molecules to complex organic chemistry, from the first self-replicating molecules to cellular life, from simple organisms to complex brains, from instinct to consciousness, from consciousness to self-reflection and scientific understanding. This is the trajectory of the universe. It's moving from simplicity to complexity, from ignorance to knowledge, from chaos to order, at least locally, here in our pocket of space-time. And you're the current frontier of that process. You're the most complex thing we know of in the universe. A human brain with its 86 billion neurons, trillions of connections, capable of abstract thought, creativity, love, wonder. When you learn something new, when you make a connection you haven't made before, when you understand something deeply, you're advancing this cosmic process. You're increasing the universe's self-awareness. This gives your life meaning beyond any personal achievement or social recognition. You matter because you're part of something unimaginably vast. The universe has spent billions of years making you possible, and now you're here briefly with the capacity to understand and appreciate it all. So what should you do with this knowledge? How should you live, knowing you're made of light, knowing you're a temporary pattern in the cosmos, knowing you're part of this great unfolding? First, appreciate it. Look at the stars and remember you're made of star stuff. Look at sunlight and remember it's the same light that powers your body and your world. Look at other people and remember they're made of the same ancient light as you, facing the same existential situation, trying to make sense of it all. Second, add to it. Create something, learn something, teach something, love someone. The universe is giving you the capacity to increase order, to create beauty, to generate meaning. Use it. You're a temporary eddy in the flow of matter and energy, but while you exist, you can create patterns that outlast you: ideas, art, relationships, children, contributions to knowledge. Third, connect with it. You're not separate from nature. You're not separate from other people. You're not separate from the cosmos. The boundaries we draw, me versus you, human versus nature, living versus non-living, they're useful fictions, but they're not fundamental. At the deepest level, there's just matter-energy information, organizing and reorganizing itself in patterns of staggering beauty and complexity. When you hurt someone, you're damaging a pattern of organized light that took billions of years to create. When you destroy nature, you're simplifying complexity that emerged from eons of evolution. When you create division, you're fighting against the universe's tendency to create connection and organization. Conversely, when you help someone, when you preserve nature, when you build community, when you increase understanding, you're working with the universe's direction. You're part of the solution, not the problem. This isn't moral preaching. It's physics. We're all part of the same system. all made of the same light, all facing the same challenge of maintaining our temporary patterns before we inevitably return to the great recycling program of matter and energy. And here's the beautiful part. Because you understand this, because you've followed this exploration from the Big Bang to the present moment, you can never see the world the same way again. You can't look at light without remembering it's the origin of everything. You can't look at matter without remembering it's frozen light. You can't look at yourself without remembering you're the universe experiencing itself. This knowledge changes you. It expands your circle of concern from yourself to encompass everything, because everything is part of the same fundamental reality. You're not an isolated ego trying to survive in a hostile universe. You're a manifestation of the universe itself, engaged in the grand project of understanding and creating. Carl Sagan ended his series Cosmos by saying, "The cosmos is also within us. We're made of star stuff." We are a way for the cosmos to know itself. But we can go further now. We're not just star stuff. We're light, organized into temporary forms, briefly gifted with awareness, experiencing the wonder of existence. And when your time comes, when your pattern dissolves, and you return to the light from which you came, you'll have been part of something incredible. You'll have been a point of consciousness in the universe, a place where matter became aware of itself, a brief candle in the dark that nevertheless illuminated some small corner of reality. That's not insignificant. That's glorious. So here's my challenge to you. Now that you know all this, live like you're made of light. Shine. Illuminate the world around you. Increase understanding. Create beauty. Spread warmth. You're not going to last forever, nothing does. But while you're here, you can make your brief existence matter. You can be part of the universe waking up. We've covered an enormous amount of ground in this exploration. Let's recap the journey we've taken. We started with a simple observation. Light and matter are interchangeable. E equals mc isn't just an equation, it's a description of reality. Matter is frozen light, light is liberated matter, and the universe began as pure energy that crystallized into the structures we see today. We traveled back to the Big Bang and watched the universe transition from the photon epoch, when light dominated everything, to the formation of the first atoms, when light finally became trapped in matter. We saw how the cosmic microwave background, the afterglow of creation, is still visible today, a fossil record of the universe's infancy. We explored modern experiments where physicists are learning to convert light directly into matter using the Breit-Wheeler process, recreating in laboratories the conditions that existed microseconds after the Big Bang. We discussed how this same process happens naturally around neutron stars and in gamma-ray bursts, showing us that the line between matter and light is being crossed constantly throughout the universe. We delved into quantum field theory and learned that both matter and light are excitations in quantum fields, ripples in the underlying fabric of reality. We discovered that particles aren't really particles at all, but wave patterns, and that the distinction between matter and light is less fundamental than we once thought. We examined how this understanding could lead to technologies that seem like science fiction replicators that create matter from energy, transporters that convert matter to information and back, antimatter drives for interstellar travel. While these remain impractical with current technology, they're not impossible in principle. We contemplated the personal implications. You're not a solid, permanent thing, but a temporary pattern in the flow of energy and information. Your atoms are constantly being replaced, your body is radiating light, and you're engaged in perpetual exchange with your environment. You're a process, not an object. We faced the question of death and found that while personal consciousness may not survive, the matter and energy that composed you continue forever, recycling into new forms, returning to the light from which everything came. Your substance is immortal, even if your pattern is temporary. And finally, we recognize that you're part of something magnificent, the universe's journey from simplicity to complexity, from ignorance to awareness. You're not separate from this process. You're an essential part of it. Every moment of consciousness, Every act of understanding, every creation of beauty is the universe becoming more aware of itself. So what have we learned about whether light is the first form of matter? The answer is yes, but it's more subtle than that. In the beginning, there was energy undifferentiated, pure potential. As the universe cooled, that energy took on different forms: photons, light, quarks, leptons, and eventually atoms, matter. Light and matter emerged together from the same primordial energy, and they remain interconvertible today. Light isn't more fundamental than matter, and matter isn't more fundamental than light. They're both fundamental. They're both aspects of quantum fields, both manifestations of energy, both part of the unified reality we're still learning to understand. But in a very real sense, light came first chronologically. The photon epoch preceded the formation of matter as we know it. And light remains the link between all matter, the force that holds atoms together, the energy that powers life, the information carrier that lets us see and understand the world. We are, quite literally, beings of light, made from it, sustained by it, eventually returning to it. And now you know. You understand the physics behind the poetry. You've seen how science reveals truths more profound than any myth. You've followed the thread from the Big Bang to the present moment and discovered that you're not just in the universe. You're part of it in the most intimate way possible. Before I let you go, I want to hear from you. Drop a comment below telling me, which part of this blew your mind the most? Has this changed how you see yourself and your place in the universe? What question do you still have about light, matter, and reality? And if you haven't already, please subscribe to this channel. We're going to continue exploring these deep questions about reality, consciousness, and our place in the cosmos. Hit that notification bell so you don't miss future videos. Share this video with someone who loves science, or someone who's searching for meaning, or someone who just needs to be reminded that they're made of starlight, and that's pretty damn amazing. Thank you for taking this journey with me. Thank you for being curious, for being willing to question your assumptions, for being open to wonder. The universe is lucky to have you as one of its points of consciousness. Now, go out there and shine. You're made of light. Act like it. Until next time, keep questioning, keep learning, and keep being amazed by the incredible reality we're privileged to be part of. This is the universe, talking to itself through me, saying goodbye to itself through you. See you in the next one.